Okay, with this video we're going to start our look at Earth's moon. And starting off, we're looking at a satellite picture, time-lapsed, where the moon passes in front of the Earth. This is one of the first pictures we have of the entire moon and Earth in a satellite image, kind of like this, where we kind of get this transit of the moon in front of the Earth. Kind of an interesting look and gives us a good view of the moon as it passes in front of the Earth. So we look at the origins of the moon, and our best guess for the formation of the moon is that it was created when a smaller planet-like object collided with Earth, and that was probably like a Mars-sized planet-like object. We call this the giant impact theory. The impact broke apart the planet-like object and a portion of Earth's crust. Both planetary bodies were greatly deformed, but due to the great amount of gravity and heat during the impact, the Earth was able to reform. So we look at our origins of the moon. We can kind of look at some of these different steps. So we kind of talked about this planet-like object coming in and hitting it. It kind of takes apart a lot of the crust of the Earth because it wasn't a direct impact and it was kind of at a glancing blower to the side of the Earth. It just kind of took off a lot of the lighter crustal material, and that's why the moon is made up of very light, not dense rock. And we can kind of see the core of that planet-like object kind of then comes back into the Earth and kind of gets sucked in. Since the Earth is still kind of hot and molten, that core kind of gets sucked in with the core of the Earth, giving the Earth a larger than normal core, which is very important for life, helping the Earth with a larger magnetic field and protecting it from the sun. And that debris ring then around the Earth kind of solidifies and eventually will kind of cool and harden and accrete and form the moon. So like it says here, this broken ring of upper layers of the Earth's crust, some pieces are still orbiting the Earth today. This debris ring made of lightweight materials begins to condense and the moon begins to collect the different rocks, and its gravity increases and cleans up, kind of like rolling a snowball and turning it into a snowman. And you start off with a very small ball, and as you keep going around and it keeps collecting more snow, it increases in size until it gets to the current size that it is today. Some features of the moon's surface. There's no atmosphere or air, so there's no sound on the moon. The temperature of the moon on the daytime in Fahrenheit would be 253 degrees, and then at night in the shade it would get down to negative 387 degrees. So wild swings. Because there's no atmosphere, there's no blanket to kind of hold in the heat from the planet. So during the day, no protection from the sun, and at night, nothing to keep that heat close to the surface. We look at some of the features of its surface there. Marias are the dark areas where lava once flowed. Craters are depressions on the surface of the moon. So we have a picture of a Maria there. And then of a crater. With the craters, we can see some of the lunar moons formed from the craters. So kind of the waves or shocks that kind of spread out from the depression of the crater on the surface of the moon. We also look at the mascons higher gravity areas where craters and might have struck the surface, so we can kind of see some areas, these three spots here, kind of lining up in the same areas as the three dots on the other side, and maybe some metals or things like that brought in by meteoroids, giving the moon's surface a little bit different density in those spots. Riles are trench-like areas. They're like valleys found in the bedrock of the lunar surface. Rays radiate out from craters, shattered rock and dust from meteoroid impacts. Regolith, the loose rock material that makes up the dust on the lunar surface. There's also a lot of small amount of water on the moon, not so much in lakes or sheets, but more water molecules. But that might be important if we decide to make a base at the moon and maybe try to explore other parts of our solar system, that we can kind of maybe take advantage of some of these water molecules or small patches of water that we find on the moon. So again, we have here the riles, trench-like areas on the lunar surface. We get these rays extending out, kind of this shattered rock dust and regolith kind of spreading out from the surface. We also look at some of the sandy kind of dust on the surface of the regolith there. We see Apollo astronauts taking some samples. We see the footprints of Apollo astronauts because there's no atmosphere, no wind or water. There's no erosion or anything like that to kind of wash away these footprints. They'll be there essentially forever as long as nothing kind of bumps into them, or there's not a meteoroid impact or something to kind of spread out some dust or dirt and kind of change those footprints. And that's where we're going to stop with this video, and we'll take over our second part of the moon and look at the orbit of the moon.